Cool. And we are live. Hello, everyone. Can you guys hear us? And as well as like see our faces. Dim light is fine. Hi, Josh. Hi, Ragul. Hi, Rutvik. Hi, Alberto. Welcome back. Hi, King of Zokas. How are you? Just adjust this. Hi, Sweta. Welcome back. Hi, Adil. Hi, Sandeep. Hello, Neha. Welcome, Hijbul. Cool. I don't like the angle of the camera, so I don't know. It's too high, too low. It's fine. Hi, Kenneth. Welcome back. Walaikum salam, Hijbul. So I wanted to show the hoodie, but it's not visible in the camera. So it's a build with Hussain hoodie that I'm wearing. Fine. Cool. Let's wait for like 1 or 2 more minutes and then we can start. Hi, Tahir. Welcome back. Cool. So yeah, till other people arrive, we can start with the introduction. So if you are like just new here,
Cool.
first episode, then just go through the playlist. There are like a lot of other episodes, and also hit subscribe. So you can just go to buildwithhusain.dev. There is a schedule up there. So today's episode is like framework deep dive, episode 13, and we do it every Wednesday 2:30 p.m. And upcoming we have episode 14 with Mayank, low code no code automation. Then there is a special Independence Day episode, and the styling is broken here. That's fine, I'll fix it. So episode 15, 16, 17. So this is total collaboration month. Tahir says hi, Ankush. Yeah, so I'm being joined by Ankush today. So Ankush is
Hi.
all things engineering at Frappe. That's what his LinkedIn said a few days ago. Cool.
Uh, yeah, so I'll introduce myself. I hope
Cool.
you can see me and hear me.
Yep, you are
Hello.
visible.
Yeah. So yeah, I am VP of engineering at Frappe. I look at framework, ERP Next, and little bit of Frappe Cloud sometimes. Uh, Mostly I am backend engineer. Some of you might already know me from Discuss or GitHub. Like, we have probably interacted there. So today we'll just I will just go a bit more into framework, how framework works, so you can get you can get better idea of how framework works when you are working on or developing Frappe apps. So shall we begin, or are we still waiting for people?
No, let's start. I will just switch to your screen share and it's visible.
Okay, cool.
Cool.
Uh, so let me know when like my slides are visible.
Yeah, audience, are the slides
Uh,
visible? And we are like in the corner as well. think there is like a 1 or 2 minute delay, but we'll get a response. That's usually fine. Your screen is
Cool.
visible, fine. Yeah.
Is th-
Yes, we got the
is there like a
confirmation.
long delay, or
No,
we
no,
can just continue? I guess
no, no. We got the
things
yes
can happen over
from
chat.
the chat. We got
Uh,
the chat.
so just let me know if something goes wrong,
Yeah, yeah.
because I can't tell from the side.
No, no. I will let you know.
Anyway, so yeah, so today's the objective of today's session is to like dive deep into Frappe framework, and this objective is sort of motivated by this principle that whatever in software engineering, whatever product software library you work on, you should know things one level down and one level above. So let's say if you are working on ERP Next, you should know Frappe framework, so uh, you have better handle of things. If you are working on Frappe framework, you should know underlying library and so on and so forth. So, like, if you know like one layer above and one layer below, it makes your job much easier. Like, there will always be cases like when you hit corner cases or anything. Like, you don't have to like just rely on docs. Like, if you have deeper understanding of things, it's much easier to solve problems or uh, build something in more meaningful way. So this session will most likely be geared towards Frappe framework developers who have at least 2 to 6 months of experience. So like if you are very new to this, like this might not, a lot of this might go above your head. But if you have used it for at least for a while, then you will at least be familiar with some of these things, and then the advanced stuff or like medium level stuff will be able to grasp that. Uh, the other intermediate level stuff will have maybe some other day, but this is meant to be more of intermediate or advanced level things. And considering today's time, like mostly just our today's focus will be on the processes or what are things in your profile, uh, how a web request is handled or the Frappe web server works, and how background jobs and scheduler work. So these three are like the last two are broadly the two major things that you work with when you are building framework app. And processes in general, you should know like what is going on, and like how to debug things or how to make things better, etc. So we'll jump straight into processes, and then I'll I'll go through them first. Yeah. So these are benches that I have. Can you see my screen now?
Yeah, yeah, the screen is visible. Just a moment. So Neeraj says some disturbance in sound loudness is good, but not clear. So I've applied a noise gate filter. Just let me know if it makes any difference. So I think there is a slight
Cool.
echo.
Okay.
Yep.
Yeah, I also feel slight echo from your voice, but not much from the others.
Cool, cool.
Anyway, so let's begin. Uh,
Yep.
if there is some problem, like just let me know later. But
Yeah, yeah, sure. You can
we'll begin.
continue.
Yeah, we'll begin. Like this is assuming if you are developing, I'm assuming you have some bench. So this is assuming you have some bench setup. It roughly has these things in it. I have some extra things which I can ignore for now. But it has these things by default, like these folders and files. So there is apps folder, there is your environment, there are some logs, and then there is a proc file. And when you do bench start, uh, that's what the proc file is what defines like what are the things that should start. So bench start is just by and large it's just a alias for control start if you think about it. Like it's just a way to start multiple processes at the same time. So if you are coming from some other background, think of it as like if you let's say you are from Django, so Django has Python manage.py, then run server, something like this is there in Django. Flask has something similar where you do Python app.py. So all those Python frameworks or libraries, they have a single command to start the web server. That's because they are largely simple and just handle one piece of it. Because Frappe framework has like 4 or 5 different services, and like it is considered batteries included. It has a lot more things, and so it requires multiple services. So that's why to start multiple services, we use something called procfile, and I'll just show you the what the procfile is and what it contains and what it does. So uh, roughly your profile will look like this, where it has a few Redis instances, a web instance, a socket instance, a scheduler, background worker. So we'll just go through roughly what each of these does, and I'll just write it down what it does here. So Redis cache is basically Redis. If you haven't heard of Redis, and by the way, the format of this file is you just give some process name and you tell command to execute. That's how proc files work. So these names don't matter much, but the command that comes later is what is being run at the same time when you start bench. So when you say bench start, it spawns all these commands in the same terminal. So you don't have to spawn them one at a time. So let's just look at each one of them. So Redis cache is basically what it says. It's a cache in Redis. So Redis is this key value store where you can store things, so this faster to access than database. So a lot of things is cached by default, like doc type schema, user data, sessions, etc., etc. So those things are cached by default, and this is where your cache lives. So this is a cache service. Then we have another Redis service. This is called Redis queue. So it's largely the same. Like it runs a separate instance of Redis server, but this is used for storing your background jobs. So if you have used Frappe.nq before, when you do Frappe NQ, it puts some kind of job here in Redis instance until it is being completed. So this is used for basically your storing queues for background jobs and stuff. Then we have one more process, which is the main process that you interact with from browser. So this is called bench serve is the command, and there are some other arguments, but the main command is serve. This starts the actual web server. So when you open desk or just go to like develop.localhost 8000, this is the service that is responding to you. So this is basically web server that you have. Socket.io is, will not go much into details about Socket.io today, but this process is for real-time communication. So when you save some document and some other person was using the document, they also get immediately notified that this document has been updated and they should reload it, or the list view updates. So all those real-time communication bits. So real-time communication server. So this Socket.io server is what the Socket server basically does that for you. Watch also is a process that we won't get much into detail today, but it is your asset bundler slash library load. So when you modify any JavaScript file or any CSS file, benchwatch runs the ES build command in background, and as soon as it detects change, it will recompile all your JS files and reload the browser. So we can demo this, but it's just something, the library load that you might have experienced somewhere else.
So this doesn't work in doesn't need like to be enabled in production, right? So this is just for development.
Yeah. So benchwatch is only for development. So we are right now looking at development setup, and we will maybe go through production setup. Production setup is largely same, with one process removed and some other process duplicated with like to handle extra load.
Awesome.
So this is the simplest setup, and then there is something called scheduler, which like if you know scheduled job type. So we have many scheduled jobs. So like just give me a sec. So scheduled jobs are basically things that you have specified in your hooks.py file, where you say that I want to run this job every day, every hour, etc., etc. So those definitions are read by this process, and this process basically just runs infinitely, and it tries to enqueue whenever there is time. So if you have said that let's say run session cleaning every hour, so every hour this process will check like have we run that job or not, and if we haven't run that job since 1 hour, then we need to queue it now. So all this does is like enqueue scheduled background jobs. And we will get into more detail with these things later, but for now, the simple explanation should be mostly enough. The last process is worker. If you have older bench, there might be 3 workers like these, but like in new development setup, we just have 1 worker. So what workers do is like whatever is enqueued in background, workers' job is to work on those things. So like work and complete background jobs is what this process does. And we'll see why this is required, or why this is required, or where when you should use background jobs, etc. When we get further into details. But broadly, this is what the main profile is, and these are all the processes that run when you do bench start, and except with exception of bench watch, these are all the processes that will also be there in production. So does anyone have any questions, or should we go, or any other? So if you weren't running MariaDB as a daemon already, you can start it from here. I don't know the specific command, but let me say somehow, like as if I am on Linux, the MariaDB is running by default only. So it is like I can stop it. So let me try to stop it, and then MariaDB you. So now MariaDB is not accessible, but I can put it here in profile saying MariaDB. I don't know the exact command. I might have to Google it, but you can probably. Well, it's probably something like MySQL D something something. I don't know some flags, but you can start MySQL without running it as a background service, and when the bench is stopped, it will also stop the MySQL. I don't know exact commands. I'm not going to do it live, but I'll maybe drop the exact command it in chat.
Yeah,
So
yeah.
prop files are any commands that you want to start. So
Mm-hmm.
even like I can start some dumb command here, sleep 10, I'll just say sleep for 10 seconds. And this will be fun because this process will exit, like I'll do sleep 5 and it will kill everything. So let's just see if this happens. Uh, so something went wrong. I don't know what. Like something always goes wrong with live coding. Wait.
Command to
Oh yeah,
exit.
yeah, it's not starting because I killed MariaDB. So I need to restart MariaDB. So now MariaDB should work. Yeah. And now if I start bench, it will command to execute not found. Okay, I need to remove this also. Like this is not a real.
Mm-hmm.
So if you see everything started, the sleep command also started. It didn't output anything, but after 5 seconds, things got killed because the sleep command exited. And in top somewhere you can probably find why it exited. No, so let me give a slightly better demo of why this happens. Let's say echo sleeping, and so somewhere it started sleeping. There is too much noise here, so okay, I found it here. It started sleeping, and after a while, since it completed sleep, it exited. So that's the simplest example explanation of what Procfile does. It just starts all the services at the same time, and if any service dies, it kills all of them. So sometimes if your bench stops from like if you have done something weird, or you haven't done update right, or some service is not running, it will crash everything, and then you'll just have to see in here like where the actual crash started.
Mm-hmm.
So in here the sleep process exited, and that's why everything else exited.
So Neeraj
So yeah.
asks, what if we enable like multiple workers?
Uh, yeah, so if you want to have multiple workers, you can just give them different name. Then all of the workers will start. So if I start this now, you will see multiple worker processes here. Uh, just give it a sec. Yeah, there is worker one, worker two, worker three. So all of the like, you can have as many workers as you want. In development setup, you don't need it unless you are like testing some behavior which requires multiple workers to be present. And we will go into details about what workers are and how they are configured, etc. when we go to background jobs. So I'll keep that question in.
Cool.
Any other question?
No, none as of now.
Cool. So that was all the processes. So now the fun part begins. Like from now, we will go and explore all the actual framework code. That just means like going through the code, reading, dynamically inspecting, just seeing how it works, or like looking at traces, etc. So there will be very little live code, but a lot of code exploration. And this is still an important skill to have, like just jumping into any random project and trying to figure out how it works. So let's say you didn't have much idea. Like I do know where all of these are defined, but if you had to find where all of these are defined, or any other command that run is defined, the simplest way to like these are external commands, but the bench commands are something which are defined in framework. So let's start with the web process and let's see where bench server is defined, what it does, how it responds to things, etc. etc. So the most basic tip that you should remember, this implementation is like every bench command is represented something like this, like command. It's so we use a library called click. So every command is represented like this command serve. So somewhere in our code base, there is a command called serve, which is handling what to do when we issue bench serve. So let me just try to find that. I will go to framework directory, and what you should do is just search where the this command exists. So command serve. Oh, there isn't any. Nice. Uh, uh, RG command serve. Anyway, let's try to find uh, it ourselves.
Maybe it's a group
Command
of command. I think then it is not dot command. That is something else. Maybe.
Yeah, probably there is something. Oh, it is
Yeah, it
there.
is command, but
It is command
what?
serve. So I didn't show up. I don't know why I grabbed it. It is called command and serve. Maybe I typed it wrong. Command serve. Oh, maybe it's this. Yeah, yeah, yeah.
Yeah.
So I forgot quotation, so that's why like it. So this is a regex. Like I want to find any command which has serve somewhere in it. So there is this command somewhere called click command serve. So this is a bench command. Like when you do bench serve, this piece of code will be hit. Code will be hit, and it will start the web server. So let's just stop the entire. We have stopped entire bench, and now we'll just run bench serve here. And what you will see is it will start the process, the web server process. And now you can hit this and like I'll just show you that this works. Like even without anything else, this works. Uh, like I'll have to type the site name and not yeah. So this works. This will be somewhat slow because there is no cache service running or anything. It's just directly reading off of database for everything. But just running bench serve also works. Like if you don't want to do anything else, if you're just working with bench, if you're just working with the front end and just this, yeah,
Disk.
uh, yeah, just a basic test setup where you're just testing how the web service works and the
Hmm.
Python side logic works. You don't need everything. You can just start with bench serve. But that's also somewhat limiting because it is not running other services. So let's try to explore like what this command does. So I hope this is readable.
Yeah, yeah,
I've
it's
zoomed it quite a bit.
yeah, it's readable.
Yeah. So Benzer hits this file in command. So basically, all commands that you issue in Frappe framework are some stored somewhere in Frappe commands folder. Like they are not in random places. All of them are like all the commands are in Frappe slash commands. So this is a command that starts a web server, and if you see, it has some flags. The most important one is usually port. Nothing else really matters much, except the no reload flag. Sometimes you want to disable it. So the development server automatically reloads you when you make changes to some Python file. And there are same defaults usually, like reload is on by default, port is set for you, so you don't have to do much usually. It just works. Uh, so let's see how this works or what this does. So when you start a web server, there is a lot of unnecessary code here. But if we could jump to this bit, this is the final bit that actually starts the server. It's calling frappe.app.serve with all these things. Now, if we want to know what this does, we can just jump to that file. Like what does serve? So Frappe has a file called app.py, which is the main web server. Like we'll get into what it does, but like for now, just know that app.py contains the main web server and all the implementation along. So we use this library called Works. It's pronounced very weirdly. I'm probably pronouncing it wrong. It's Budzog or something. It's German word. Uh, so Workzug is the library that we use for request and for handling request and responses. It provides a lot of utilities for us, so we don't have to do like very basic HTTP request passing or response passing, etc. This is also the same library that Flask uses. So if you have used Flask, you have probably heard this word or seen this somewhere in your code. So it is the same exact same library that Flask uses. Uh, and so when you do start, what we do is this: we import run simple from Worksuite, which is like a simple web server, and here you can, if you can see what we are doing here is. Like we are picking up site etc from default, and in the end there is some this is the call run server. Run simple is just this worksuite command to start the web server, and we are basically starting worksuite web server when you say start Frappe web server. Now the important bit here is this application. Like so worksuite like will go a bit random here. So
That's fine. That's fine.
yeah,
Yeah. Let's
so
go. Yeah.
the yeah, so Workzug or in general Python has this standard called WSGI or WSGI. I can show you WSGI Python. Uh, yeah, this is the one. So like, this is very boring standard, which you don't need to read entirety of it, but it's been there since long time, since like probably 2 decades or so. So this is a standard defined for building Python web applications which can talk to other web servers like Nginx,
Apache.
Apache, etc.
Yeah.
So these web servers follow some strict protocol, and if you have to talk to them, you have to build your web server which is compatible with this. So what this requires is like we also have another web server in between called Unicorn, but like what basically it requires is you need to define an application. So we'll go to this. Like this workzug is asking for which application to serve. And if you have worked in Flask or Django, there also you will have something called app is equal to flask.app or something. So this the same way Frappe has one application globally. You don't ever have to write something like this again, but just knowing what this is helps a bit. So I'll go to the application that we have. So this is our application, the main Frappe application. And I'll collapse all of this. So only the important part is here. Uh, yeah. So there is some 50, 60 lines, but you can ignore all of it. The basic structure of any web application in this context is you receive a request and you provide a response. That's about as simple as it can be. Like you receive some request which has a path, which has parameters, which has some JSON body, any number of things it can have. And all you do in the end is you return a response, which is a HTTP response. It can be JSON, it can be text, it can be anything. So all the magic that happens when you send a request, it happens in between these 50 or 60 lines. Of course, like it is just beginning of things. Like as you go down as
Yeah.
you
Yeah.
peel the layers of onion, there is a lot more code that runs. But
Exactly. But the
uh,
simple concept of across all framework is the same, right? The
yeah,
backend frameworks receive request, provide response. That's it.
yep. So that's the simplest explanation of what most frameworks do. Uh, so this is the app.py, and if you ever want to like understand this, you can jump to this and see what this does. So I'll not walk through like each line of this code because a lot of that is boring or handling some edge cases. But the simplest explanation of what request response IFL is, I'll go through that. So we just set the response to run because we might not have some response, and then we begin doing the request, like handling the request. So the first thing we do is initialize the request, and now here the fun part begins, or rather the interesting bits begin.
Mm-hmm.
So when you get request, we set the request to something called frappe.local.request. So you might have a lot of time handle like try to do frappe.request.path or something like this. Like you might have accessed this in code. So how this works is like every time a request is set, we set it to a like it feels like a global variable, but it is not. So I'll explain what that is. So there is this fun thing called local, and to see what it is, we'll have to jump to that definition. So I'll go to where local is defined. So local is defined on very top of the main Frappe init file. So frappe.local is what it is, capital local, uh, which is imported from where. Okay, you'll have to see it's imported from worksoup.local.
So Ritvik
So
asks, so because of this, we don't have to tell each time what type of request we are sending, like post, get, patch. Didn't
uh,
get your question.
no, not really. So that is a different thing. We'll get into it a bit later.
Cool.
So we'll first try to understand this local concept. This is somewhat important to understand how request or jobs are handled.
Mhm.
So here we'll search what is Workzip local. It is this. So it is called context local. Uh, I mean, this is wait, this is old documentation.
And
Anyway,
it's like
new
minor version
documentation.
old. Yeah.
Yeah, it won't have anything else. We can ignore what it says. So basically, frappe.local is a context local. So context local means it will look like a global variable to you, but like obviously putting global variables is a very bad idea. So it looks like a global variable, but it is very specific to that request only. So anything that you put in local, like frappe.local.request, only lasts until the request is there. So
Okay.
once the request is gone, the frappe.local.request is replaced with some other thing. The same way you have frappe.flags, you have many other things. So we'll see what those are.
So
So
here's a question from my side. So this local, like the variable is defined only once, right?
yeah, so Frappe deep. So if you do look at Frappe in it, we
Mm-hmm.
define all these local globals, which are called local globals, but these are like global variables which are proxies. So when you do frappe.db, it just goes to frappe.local.db. It's a sort of a proxy.
Right, cool.
So every time that's how you can even have multiple databases connected on the same server without like still all of them calling frappe.db only. And
Mm-hmm.
by the way, if you have worked with Flask has something called Flask.g, which is the global namespace like
Mm-hmm.
this, which is
So
very similar. So
Virjuk take cares of cleaning it up after every request. Is that right or?
yeah, Workzip provides a way to clean it up. Like we still clean it up ourselves,
Okay.
but like you don't ever have to worry about cleaning it up. Like if you put anything in frappe.local, it gets cleaned up after it gets cleaned up after the request. So
Cool.
just only in that context you have something. So all these things basically like frappe.form, frappe.request, frappe.response, session, frappe.user, all of these are proxies which are set for you when the request is arrived. And we can see how those things are being set. So if you look at this, we just set request here as soon as request arrived. Then we also, like, if you know how the multi-tenancy feature, we also need to see for which site this request is coming from. So we look at site's header, which will tell us that this is like dev.localhost.com and not something else. So we set the site here and then we initialize the site. So this is where all the initialization of locals begins. And we should look at that instead of other things because here nothing else is that important. So if we go to Frappe init, uh, this is where the journey of every request begins. We clear all the local things, even though they are automatically also cleared, but we initialize them with the empty version or
Yeah,
the
proper.
default version.
Proper defaults. Yeah. Cool.
So we set all of these and like if you see here you can see frappe.local.site like which site this request is for. So if you want to see that you can check that here. And there are other things like conf is the configuration. So if you are trying to inspect in a request what is there in site config or common site config, you can just access frappe.conf and that will be updated with that particular site for that particular request. So that's how like some of these global things which appear very simple are done. Every time request is set, we initialize them with the right value. So whenever you write your application level code, you get access to all of this.
Cool.
Uh,
So
there are
Sabu
some more
asks,
things.
Sabu has a question. So Sabu asks, can we inject custom properties to a request?
Properties as in what?
Headers
Uh,
or something else?
so request is coming from client. So
Mm-hmm.
there from client side you can add any headers and stuff. From
Okay.
server side we have access to frappe.local.response and headers also somewhere. So we'll get to that, but yeah, basically you can. So if you want to send before response, you can update the headers of that response with something else uh, if you need to. Mm,
Cool.
yeah, where were we? So we were at locals, right? So
Yeah,
now
locals. Mm-hmm.
basically the request is initialized with all the site information, etc. And now the next step here is connect. Connect doesn't do much. It just connects to the database. It gives you the database instance. So we get the database according to which database you have, and we just read the configuration for your username and password. So it is just giving you a connection to database. So that's all connect does. Everything else here is not that useful, but I'll just give you make form it. This is another somewhat useful thing that happens. So make form dict is like any so because there are two ways to send arguments to any request. One way is query parameters. So you might have heard query params are something like this, like where you have API then uh, key equals value, something like this. And then there is a form data or post body, which can be many formats, but ultimately like they are just like a key value sort of arguments that you send. So when those things are sent, uh, we just parse all of them in some sane way and just give you a dictionary, which is the form text. So you can access this and see like what is the user has typed as a uh, what is the query parameter or what is the body. We just merge all of them, and then from any network request or any API endpoint that you have built, like all of these get passed out to those functions. So we'll see one of the examples of these after we are done with the explanation. So this is init request. We lost it a bit. Uh, then we begin by doing this validate auth, which basically logs you in if you are using the authorization headers. And so we'll not get much into those details, but the important bits is here, these two things. So if the form dict, so after we have passed the user arguments or the request arguments, if that contains a command, then we use something called Frappe handler.handle. So let me just show you how this works. It should be better than just giving me walking you through entire code. So let me start a bench and let's go to yeah. So there is this neat functionality in build called recorder, which records every request and gives you everything that happens. Like it gives you stack traces of everything that happened, etc. So I'll start this and then I'll send a very dumb request, nothing complex, just we'll just do API slash method slash ping, which just gives back POM. It's just a simple request to see if the site is up or not. But I'll stop the recorder and we'll see that this request was registered. So recorder, I'll not explain much into detail right now, but it's basically a profiler for looking at all the SQL queries on all the requests that are made. So I recorded what went on right now, and this is what happened. So we received a ping, uh, and it had all these headers. It took 1 millisecond, but the important fun bit is here. So let me see the first query that happened. Yeah, here. So if you look at this, we hit frappe.app application. Like I said, we will hit that some point. Then this is somewhat uninteresting. Let me do something fun. Let's break this somewhere. Where can I break this? So this is fun thing to explore on your own. Like if you just randomly break things, you can see where they break, and then you can see what it is running. So I'll just try to do this again because this didn't give us a entire good trace back. Uh, nope. Ping. Yeah, ping. This is the one. There is exception. Not allowed. So I will record again. We'll do this. It will
Yeah.
likely fail. And now we'll have much better idea of what happened because we'll get the entire trace back, I guess. So let's execution order reversed. Still not so good. Anyway, so I'll just walk you through because like I can't reproduce the exact example. But basically, when you send a request and you say that this is the thing, like API method ping, this ping or like you can send other things also, like you can send frappe.ping here, or you send other like many like whenever you do frappe.call, you specify some method to call. So all these methods are called CMD or command in Frappe language, and those like commands are set here, and we can go through them and see how it works. Like let's first start by just printing what the commands are. Then it will be easier to understand. So here is this frappe.form.command. And if we now do this exception, yeah, so if this is successful, just let me run something else. Anyway, for some reason it's not printing anything. But basically, like if the command is set, then it goes to handle that command. But let's jump through this. Like it would be better if I just walk you through all those things that it does. So and the next one is API. So all the REST API bits, like you might have seen this Frappe REST API. And also, okay, I made up a mistake. Like what we do is being handled by REST API, not the other thing. Anyway, this will be better to explain. Uh, yeah, so here we have this RESTful API for accessing any document or getting list of document or getting particular document. This is common across all doc type and it's implemented automatically. So let's see what how it is handled when you do like a REST API call. So if I do API/user, API/resource/user, it will give me this list of user. Now this will be probably more fun to check with recorder, like how it did that. Let's go to recorder. And so if we run this query, we get this record of it. And it ran some query somewhere for getting all the user list and users list and sending it back. So if you see now, we can get much better idea of what all went into all of this. So the first thing that happened was application was called. In application rerouted to something called handle in API.py. So here, because the request path started with API in our app.py, it basically offloaded the job of handling this request to API handler. And this API handler has a lot of things it does. One of the thing is handling resources. The other thing is handling individual documents or list of documents. So it basically came here, and if you look at this, it's fairly simple to like peel through the layers here. So we did a resource here. So we just check whether here the API handler is checking whether you ask for a method or a resource. So because you ask for a resource, we call another function which handles resources. Here we check whether you specified the name or just the document, doc type. And because we only asked for a doc type, which means we asked for a list, so we handle the doc type resources. Then we see, like, are you trying to get the list of document or are you posting the document or creating a document? So we go one level down and then it's just a basic get list call that we are trying to get list of all documents. And somewhere here, we might have called the get list and given you the document. So if you see this traceback again, it's the same thing happened. So we went to handle resources, and then because it was a doc type resource, we went to doc type resource and just got the list and sent it back. So the sending it back is not that fun, but mostly this is how the routing of API request work. We can do the same thing with something else. Let's let's try. Wait, let me.
Maybe whitelisted API. I don't know.
Yeah, let's try whitelisted API. So let's create a fake whitelisted API for now. So Frappe init. Let's create one in somewhere in user dot yeah utils.users.py. This is weird one. So let's
Works.
do Frappe whitelist. Uh, def API call return. We aren't doing anything special, but we want to see like how this is handled. So this is in frappe.utils.user.api call. So we can call this in our browser also because this is just a GET request. So API method frappe utils dot user dot what was the name API call. If you do this, you get the same like you get the response you expect. You can change the response and make sure it is exactly what you are. Let's give it form, and yeah, it gave you the response back. So now we want to understand like how this thing happened. So recorder won't capture it unless I do some kind of query. So for sake of like let's try to get something from DB from get list Flappy get list. Let's say users, and we send the users back. A very dumb example, but you might have something like this someday. So so now we are getting list of all the users back. Let's see how this actually happens. So I'll clear all the requests. We'll start recording. We made the same request again. Now, if you go and see, uh, this request was made, like you get the entire trace back. So, uh, wait, this is not it. Let me,
Yeah, it just sometimes the recorder caches stuff. I don't know.
yeah. Anyway, so this was a command that we wanted to execute. Like this is a command or a, like it's like a function somewhere defined. So that's why it is specified as a command. And you will see that where that query was made. So we went to application as we expected. Like everything goes to application. There is no other entry point. Like all web requests go. Then it went to like uh, it went through some different places, but it came to handler. So handler executes the command, uh, and we will see how it executes the command. But it executed the function we called it to execute, and then it gave you back the results. So let's see how that bit works. So if we go to handler.py and we did the execute command. So this is what it is doing. So basically we got the command here and we ran execute command. So if you want to print command here, now we should print command and see what it is getting. So let's try to run this query again. And if you see the command was this frappe
Cool.
utils API call. And what we do here is we do a bunch of things. Because we allow overriding commands, we first check like if this is overwritten by some other app or not. But
Yeah.
if you ignore this, the next thing we do is like, is this a server script? So because we support all these other things, like it is somewhat complicated, but for sake of understanding, let's just ignore all of this. The main thing that happens is do get getter. Uh, get getter is basically get attribute. The full form would be get attribute, which gives you the actual attribute defined by the dot string. So let me give you some example of this. So I have somewhere this frappe.ping is a method string. I can't execute this. I need the actual function that it represents. So if I do frappe.getAtter method string, I'll get the method string. I'll get the actual function, which is the frappe.ping. And then I can execute it and it will give me bong back or something.
Oh, okay. So it's basically taking the string and like returning the actual function and then you can directly execute. Okay, that's what behind the scene it is happening. Oh, got it.
Yeah. So if like it's also not that hard to understand. If you go inside, you will see what it is doing. It is like first trying to find the model and like just from that model, just like it is just doing some dynamic magic to import thing for you. So if you
Okay.
specify in some different app, it will import that module and give you the attribute automatically. So just simplifies not having to write the like do routing or specify from where to find it. So this happens in a lot of places, by the way, like in background jobs also. This is the exact thing that happens. Like if you specify string, it will find the function and then execute the function. So
Mm-hmm.
we found the function. These are some exception handling. You can ignore all that. Then we check that if this is another edge case handling, you can ignore all that. But we just check whether this function is whitelisted or not, because request can only call something that is whitelisted. And if it is with the valid HTTP method, like you can block get or post if you want to. So if all of that passes, then we just call frappe.call. And frappe.call is another slight dynamic magic where you can just call any function with any random arguments. So I won't get into too much detail of what it does, but basically this function is probably expecting some arguments, and we will give whatever argument user is specified to. And this handles some things magically, like if the function doesn't accept something and user has sent it, it will just discard it from uh, calling it. So let's try that. If you, let's see if we want to see, let's do argument one, argument two, arc one and arc two. And for now, we'll make it optional because we don't want to break everything that user does also. And we'll do print arg1. Print, what is this one? Arg1 equals arg2 equals. It's just one little debugging hack where you can print values with their variable. So we'll see what user has
Oh,
sent,
that's
and
cool. So I didn't knew this. You can like suffix with equal and it will.
yeah. So if
Okay.
we do this, it is giving you none right now.
Oh, okay.
Uh, we can call it with something. Arg1 equals a, and then it will give you. It didn't give you anything. Okay.
Let's find
Uh,
out why.
no, I misspelled it. It should work. Yeah, it is working now.
Oh,
So
okay.
then you get the string here. Uh, Now let's say you pass something weird here, uh, like I just did by mistyping something. Like if you say unsupported argument equals something, like that is not passed here at all. Like what otherwise would happen is like function, the Python would just reject your function call and say "Ki, this argument is not supported." So uh, Frappe just by doing frappe.call, we just take care of all the unsupported, removing unsupported. So we just see what this method accepts and
Mm-hmm.
only then call it with that argument. So that was handler.py. Uh, so this is where all your API like frappe.call or API call are handled. Uh, these two things are pretty clear now, I guess. Do you have any questions regarding these?
Let's like take 2 minutes for the
Yeah,
question. Yeah. So do you guys have any question? So there was one question, like maybe you will take it later, but it is like how app.txt and app.json is made. So Ashish has asked this.
uh, bit out of here, like not related to these, but apps.txt is made by Bench. Framework doesn't do much there.
Mm-hmm.
So when you install app or remove app, it basically just looks at the apps folder and whichever are valid apps, they are just thrown into apps.txt. So there is not much else to it apart from that.
Okay. Basic file handling,
Apps.json
yeah.
is also apps.json is also similar, but it does some resolution magic where it, if let's say ERPS depends on Frappe, so it stores all the dependency resolution. Uh,
Cool.
so these are the two topmost things that happen in uh, request handling. There is one more thing. Like these are all edge cases. You don't need to look at those. We can ignore these for now. The last important thing that happens is this: like when it is not API call and it doesn't have any command to execute, that mostly means you are trying to access a web page. So I will show you by printing here request dot method, and let's try to go to some page like just home page. So home page is not some. It's not an API call. It's not a. It's not some command you want to execute. It's just like you want to give me this page. That's it. So if you do this, you get request.method, request.path. So if we print both of these, we will see it coming here. We are doing get slash, so get the home page, and this happens indirectly by like you are also loading website script because we loaded the website. So every request that is not API or handled, by and large, goes to this. And this is whole another piece of the web server bit, which is resolving all these requests. Where like what page to show, because we support multiple ways to show pages, right? There is a desk, there are pages, there are web pages, then there are portal pages. Uh,
Yeah.
you can have plain HTML pages in www directory. So there is a lot of things that happens, and this function basically takes care of all of it. So, and by the way, this I'm just jumping to the actual definition by doing like VS Code also has, if you do command control, it will go to where it is defined. So if you have set up some LSP, so we'll just explore what this function does. So this is specified in serve.py, which is the web server for all the pages or non-API things, so all the page like things. So here you, and this was refactored in V14. So if you do V13, it will be slightly different, I guess. Uh, what it does basically is there is something called path resolver, which takes a path and sees like who should be responsible for responding to that path, and that path resolver gives back who can render this, and then you render the response, and the response is sent back. That's the most simple explanation here. Just like web server, this is also like it is getting a request and it's just sending a response. There is not much to it. Uh, there are some things in between, like all these are just exception handling, where a page not, if the page doesn't exist and we show 404, or if the page is saying that you need to redirect and we redirect to some other page. Uh, all of that is not that interesting, but how this path resolver works is probably more interesting. So path resolver is a like our business logic for resolving where something should go. So let's see where how this works. So first thing, like there is just one main function here, which is resolve, like resolve a particular path and just tell me where it goes. So what it does is first it sees like is this a redirect or not, because this is happening in terms of priority. So the first priority should, in most cases, be like, is this supposed to be redirected to something else? So if you have set up redirect in your hooks.py or in your website setting, then this piece of code will check whether this path should be sent somewhere else. And if it says it, let's redirect, then we just redirect to somewhere else. Or the fun part begins, which is the actual resolution. So actual resolution has some things like, again, this is hard coded. You can ignore this. Like even if we didn't have this, it would still work. But for sake of performance, like some things are just hard coded. So app is when you do this dev.look, when you go to the desk direct, the desk URL. So that is handled as a template page, because desk is just a HTML template, which boggles people's mind when they tell them like indirectly like it's not something crazy, it's just simple HTML page that is going to client, and then the HTML is getting loaded. So if you start feeling like, you will see like in the end it's not that complex. So let's ignore this for now, because it would have been resolved as template page even if we didn't have this. So I'll just announce this. So this is how the rendering happens. So we support something called custom renders, again something complex, not no need to get into it now. But this is these are all the types of pages which can exist. So like there can be something called static page, which is just there in some folder. There can be a web form, there can be document, which is what you see on portal. Then there are template pages, which are just HTML pages. List and print are like what you expect. List is a portal list, and print is what you get when you do the print unit. So these are all the renderers, and they can render some subset of pages. And so what we do is we try to render with each renderer. We ask like, can you render this page or not? And if they say they can render, then we just return this render, and the serve will render the actual document. Now, how each one of them decides whether they can render or not, it's up to them. So maybe we can look at a simple one, like template, a static page. So in static page, can render like, let's say, can we render a particular static page or not? It just depends on whether that file exists or not. So if that file path is valid and if that file path exists, then we can probably send it. Like it's just the HTML file that we need to send back. So here's the simplest example. There are a bit more complex example, but let's look at the another interesting one, which is the template page. And by the way, all of this is documented. There is a route resolution document page, which you can see, but looking at the code somewhat helps. So if you look at this is again like if we see like this is initialized with some path, and we try to find a template for this path. So like slash app is a template somewhere. And if we find the template, then we can render it. So the can render is checking like if we have the template path, then we can render. So let's see maybe example of this. And the best example is desk. So when we go to this, like a better example here would be, let me remove this, because in front end, all the JS is loading and everything is getting, like you don't see the actual thing that is happening. So right now I'm viewing the source, so it is just giving me the bare HTML, which is the first response that you would get if you didn't have like a proper browser. So this is the first response that you get, which is a lot of HTML with some SVG icons. You can ignore all that, but in the end, there is some audio file which happens when you change. Right? But if you look at the most important and the fun part is here, the script, and this is entirety of like with these scripts, and plus these scripts are entirety of the desk. What you see on desk with the form view, list view, etc. They are all loaded by this. So
All the JavaScript.
yeah, all the JavaScript is loaded from here. Everything is happening from here. So let's maybe dive a bit into how this is done. So since, like I said, app is a template, so there has to be a app.html somewhere. So let's try to find app.html, and it is there. Like if you see www has app.html, and if you compare this, let's go somewhere below. Like this script, uh, what I showed you in browser is more or less the what you see here, with some templating, of course, because like here we are dynamically injecting some things. The rendered version has all of those variables stripped and replaced with their actual values. So if you see this and you see this, they are largely same because this is the rendered version. And so how this happens is the template page will look at this template app.html and render it and send it back. And rendering it means like resolving all these things and like all these variables that are set. These are all just Chincha templating by the way. And if you again if you use Flask or Django, it's very similar. Like this gets replaced by the value of dev server. So here you see dev server one. That means this is the developer server, and uh, it is set from here. Now, if you want to see like because you can't write like complex logic in HTML, we also have app.py. So the one that this is a sort of a confusion. So there is app.py, which is the actual web server, and there is app.py, which is what you see on disk. So
Yeah,
the
it's basically the context file of that
yeah. So
particular, what do you call, portal page.
yes, for yeah, each page you can have a context file, and so this is it for app. So here we write just one function and we specify context, and app.py just specifies like what is the boot and like what does this user have access to. Like it gives you a lot of detail, like which is required to initialize the client side app. So this is specific, but doesn't matter. But if you want to see what, like if you want to understand how the disk is loaded, you should probably read this. Like it just gives all the
Or if
context.
you want to build like a Redis and disk or something, just copy
Yeah,
over these two files and then edit in your custom app. Maybe.
yep, yep. So then you can, if you then you can have like a app to or desk or whatever, like completely
Yeah,
different, completely custom
completely
desk,
different. Yeah. Then you
which
are not
you
limited by just white labeling, right? Then you have like your whole admin interface under your control. Cool.
yeah, but then you'll also lose everything that you have done. Like you'll have to do it. But basically, like, if you start feeling things, like, you'll find very easily where things are defined. Like it's the and most of the code is largely readable, and if it is not, we try to make it. So that was about web pages. if you see all the, like we'll go back to the path resolver. So path resolver, once it resolves like who can render this, it just asks it to render, and rendering is again like largely boring thing. It is what you would expect. It will pick up HTML template, it will set context and convert it to JSON and send it back. So that's all renderer does. Uh, in this, there isn't much else. But sometimes if you are like let's say you somehow got into conflict and you want to resolve like why this page is redirected to that and not that, etc. Then like putting a breakpoint somewhere here in path resolver can help you. Like why my page is not getting rendered by something that I did versus something that is present in ERP and extra framework, etc. So like knowing where this is defined helps you debug those issues or understand those issues better. Uh, so we covered API, we covered router. We haven't covered the request hooks. So we'll go back to app.py again. Let me clean up some of this. So this is a relatively recent feature, I guess, only after B14 this was added, uh, where where we allow you to run few things before request starts and after request ends. So if you go to hooks.py and see request, let me just find monitor. Yeah, before request and after request. So I don't know why this is formatted this way. Yeah. So before request, we start recording, we do monitor, we apply rate limits, etc. So all these things are executed before every request. All these things are executed after every request. So if you want to extend it, you can extend it from some other apps also, where you just specify which function to call before and after request, and you will get access to the request and do something with it. So if you want to see one example, so the recorder tool that I was showing you, uh, that is also triggered by this hooks only. So I'll just show you, just go to that example. So in init request, uh, somewhere here we call all the functions which you have asked us to call. So we just call the recorder.record. So you can go to record and there is a function called record here. So this is being called, and like you can do arbitrary things here. Like, there is nothing preventing you. Like once the request is set, you can access the Frappe.request, and if it is from some endpoint, then you do something else. Like it's complete freedom because it's just Python code. You can do anything. So in this case, it's just checking like if the recorder is enabled or not. If it is enabled, it starts recording everything that is going on, and then you can see it on user interface. So this is a simple example, but there are complex things you can do. Framework doesn't do anything complex because we can just write the code directly instead of using hooks. Uh, but if you want to modify this behavior of web server completely, like before, after, do something else, then you can do it.
Yeah, in your custom app, just like use the
Yeah.
hooks, right? Yeah.
Uh, People have done some good things with this, like extra validations or
Some
some.
logging to third party or something like that, maybe. I don't know.
Yep. The last interesting button web request is DB transactions. So we'll cover that roughly. So let's go to application again. Here you see this flag getting set rollback. Uh, so in between this, like the whole request response cycle, from request to response, you might do a lot of things because here you are calling just random functions in some app. Like Frappe doesn't know what you're doing. It is calling something like you might have just queried some data, in which case it is totally safe. But you might have also written some data to database, for example. So if everything went right, like if there was no exception or anything, we want to commit that data to database. So let's say you inserted a user, so you want to make sure that that commit is made. So if you have used other like if you have used other libraries, what you have is something like this, where you get let's just say db connection is equals to db dot connect and something. Then you have a cursor is equals to db connection dot cursor. Then you do cursor dot execute.
Execute, yeah.
Like it's quite involved.
Mm-hmm.
And like it gives you more power. Then you do cursor dot fetch all uh, to like get everything, and then ultimately you do cursor dot commit to uh, like somewhere you also do update. It's quite involved, like and and we get that sometimes you might need all of this, but in most cases you just need something like this, like Frappe SQL, just execute the query I have. Like I don't want to do all the dance or this SQL cursors. So to simplify all this, we have a somewhat sane model where you just issue queries like you want to, and if the request was supposed to commit, like if you have made a post request, then whatever changes you have made are committed. If you have done a get request, then whatever changes you have done are rolled back just automatically because get request shouldn't be writing it. Uh, so that implementation is right here in the application file. So we just keep track of whether we are supposed to roll back or not. And if some, in the end, we just do sync database, which is like there are some edge cases here, but largely if we are supposed to write in these methods, like these are called unsafe methods like post, put, delete, patch, like all of that, these are allowed to write. If those are the methods and we have made some changes, then we do a write. And if those are not the methods, we just roll it back. So we don't commit and we roll back. So commit, roll back, if you already know the transaction, this is where it happens. And there is a document somewhere, Frappe database transaction. So in this, I'm zoomed in, so it looks very weird, but yeah, here you see like this is the description that is present here. So any post, put, delete, etc., they will write, and if there are any exception, they will throw it back. So let's see where the exception happens here. So if there is some exception, then uh, like we handle the exception somehow, like we return the exception code, etc., etc. All that is sort of boring, but the rollback stays like rollback is already set to true. So like for example, rollback will be true here still, and we don't hit the else block because we hit the exception. So we don't commit and we roll back everything finally. So this is the case where we roll back everything. Then we run the hooks, which we already saw. So understanding this bit, the documentation explains what it does, but like just understanding this in code sometimes helps you get a clear idea of why some write is not being made, or uh, where you might need to commit yourself. Like if you are using get request, then you might have to commit yourself.
Okay, okay. So I recall this like in the last time's training, people were writing their own what do you say custom endpoint using frappe.whitelist, and it was not updating the user sum. So some document it was not updating. They said, okay, this works and why doesn't this work? And so now I get why it is, because like they might be doing get request and then not doing commit, right?
Yeah,
And they had to do a
yeah.
manual
So
commit.
like
Yeah.
usually,
Mm-hmm.
if you need to write something, you have to do post request, and from Frappe client, if you do frappe.call, by default it always does post, because that's most sensible one in case of like Frappe
Yeah, yeah,
calls.
I recall it was
Uh,
from, I
if
guess,
you do get,
Insomnia or Postman. They were calling it from a third party, what do you call, API client. Yeah.
yeah, yeah, in those cases you have to set the types correctly, otherwise it won't commit anything. And
Mm.
if you see something like this happening, just look at recorder, because it just gives you very clear idea of which queries are running, why something is being rolled back, etc. You get a much clearer picture.
Cool, cool.
Uh,
So Faris has
so
asked,
that
will you take this question now or later?
No, so we are done with web request, so we can take questions.
Yeah, yeah. So can you completely override the framework's handling of request by using before request, after request hooks?
Uh, I don't think so. uh, because let's say here the request handling begins. Um, no, I'm afraid no. You might find some very bad way to like ignore all these and just set the response yourself. But I think it would be very hard right now. It should, like if we want to enable it, we can say like just add a hook and let someone else completely handle the request. But completely handling the request is not possible right now. These things will still run. You can override what they did or do it differently, but there is no way to stop them from running completely right
Yeah, yeah. Yeah, it's like very advanced use case maybe, but because the framework,
now.
yeah.
There are some, we support some custom renders where, so I'll give you that example. So like when I showed you the page rendering bit,
Mm-hmm.
here there is the path resolver has the first thing which is called custom render. So you can have custom render which behave like a renderer. So the interface is defined, and they can probably override the rendering completely, but you cannot override the API bits or the command handling. So you can do it for pages for sure. So if you have a custom render for a particular endpoint, then you can do complete rendering on your own, uh, where you define how the response should be.
Cool. So does this take from hooks, right? Page renderer. Yeah.
Yeah, you have to specify a page render, which looks like which roughly looks like the renderers we have, and
Mm-hmm.
it follows the same interface. So if
It will
it
be a
should
class.
have,
It will be a class, right? Yeah.
yeah, it has to be a class which has two methods: scan render and render. And if it satisfies the requirement, then it will be used instead of some other things. So here
Cool.
it's just a loop over things, right? So here we are just going over all of the renders, and whichever renderer says yes, we just respond with it. So you have option to override all of them by custom render.
Cool.
Any other things for web question?
Uh, no, we are cool for now.
So we sort of missed one bit where uh, all of these things are giving you responses somehow, but in the end, like let me go to that example of ping, which is the simplest one. Yeah, ping. So here it is returning a string, but converting the string to some kind of usable HTML, sorry, HTTP response is still being done by something else. So if we let's just look at the script. So in here, the last thing we call is build response.
Mm-hmm.
So Frappe.response keeps getting called with, like it gets updated with whatever the response should be. So your response here is the found or whatever, but that needs to be still converted to JSON. And it's not very interesting to be honest. Like we just convert that dictionary to JSON. That's it. So there are some other things here like how to map CSV, like how to map different types to like serialize them so we can send them with the response. The docs get serialized as a JavaScript object, for example.
Mm-hmm.
So that happens here in response.py. And you can read if you are interested, like how different things are serialized. Tracebacks are serialized as a piece of text. Okay, let's move on to the next thing. If there isn't much else left, the next bit is background jobs. Background jobs has two parts. One is just background job, and the other thing is scheduler. So we'll start with the basic background jobs. Uh, you have seen this function called enqueue probably, which takes arbitrary arguments, arbitrary keyword arguments. So there isn't much you can get from reading this. But if you read the document, you will understand that it is used for enqueuing some kind of method to be executed later or by executed by a background. So you might have already used this if you have used framework, but if you have not, the basically the point of this is to defer some kind of expensive task or some kind of long running task to background so your web workers aren't blocked. So let's say you are trying to submit a period closing voucher like in ERPX or some large stock entry or some large document which might require a lot of processing. It, like it takes 1 minute of time. you can't have that be running in the request, because even if the connection breaks down, the request fails. So that it can go wrong in many ways. So as a rule of thumb, like something that takes 20 to 30 seconds, you should probably put it in background and not do it in the same request, uh, if possible. If not possible, you'll have to handle it somehow. But wherever possible, if you can use enqueue, you should use enqueue so it goes in background. You should be also be aware that when you start using this, it is obviously gonna introduce a whole new set of complexity, because the whole simple you get a request, you respond with the response, that model is gone now, because now you are enqueuing something, and whatever work was supposed to happen will happen sometime later. So this is sort of an asynchronous behavior where, and that work can fail also. You don't know if it succeeded or not. So when you start using this, you better have a good reason to use it, because there will be complexity with it for sure.
Yeah, yeah. So last, I recall, like in episode 10, 10, yeah, I guess. So I used it to basically, so there was an appointment booking form. So you submit it, and then the sending of the message is enqueued, right? The request to basically Twilio, that was enqueued.
Yeah, so network calls, emails, etc. Those things are a good candidate for enqueuing and not doing synchronously, because sending email can take like 20, 30 seconds if the receiving end is slow. Like that can happen. So you don't want to block your request for it. Uh, so let's just try to do something very dumb to begin with. Like can you, let's so let me do here. We'll do console, and we'll write some kind of function. I have written this before. Okay. So we'll write some kind of function where it does nothing. It just sleeps for a while, so we know that it ran or not. Like import time and time dot sleep for the duration. It's a very simple function. It's just it doesn't do anything. Uh, we'll try to simulate like a 10-second job with just by specifying duration, or 30-second job by just by specifying duration. So like, now if I do frappe.enqueue sleep, uh, duration is 5 seconds. Firstly, it is like good thing to know. Like firstly, it is telling me that Redis queue needs to run, otherwise it won't run. It cannot enqueue. So the nice segue to what we read today morning. Sorry, like we discussed like an hour ago, where Procfile has multiple processes, and one of those processes is probably not running. Not one, like all the processes are not running right. So, so we need to make sure that Redis queue is running. Then only we can put this job in the queue and make sure that it will be executed later. So I'll start the bench again, and everything is running. Uh, Now I do enqueue, and I still get some error, like it's saying can't pickle the function, attribute lookup, blah 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 blah. Uh, it's a fairly weird, complicated error, but like if you understood why, or sorry, how rather how this background jobs work, you would understand why this can't happen. Like you cannot define a random function and just say enqueue it right now. And this same error people run into a lot of time, where they define the arbitrary function at runtime, like some lambda function, and they just say, uh, run this function in background. That cannot happen, because when you send this in background, it is crossing the entire process boundary. So you have this process, which is this console, which has something defined, and there is going to be another process called background worker, which is going to execute this. So you cannot transfer this across. So the first thing you should understand is any function that executes as a background job has to be defined somewhere in the code. And so because both processes share the same code, so we'll try to now define this in somewhere in somewhere in our code. So for now, I'm just going to use the same file we used in before. Right. Something messed up. Cool. So let's just define some function which we are going to execute. Let's define the same function. Okay, copy paste. This is just IPython problem.
Yeah, yeah. So this is like, I don't know. I've been frustrated by
Yeah.
this thing so many times.
So we we have just have defined now the same thing here in user.py. So now we can probably execute it. But now we cannot just say any function. We'll have to give the name frappe dot utils dot user dot c, and it should go, and it gives you back a job. And if I define, by the way, neat trick, if you forgot to assign something, you can just access the underscore and you can assign it. So now we have the job object, and I think we can probably results. Result. Anyway, this is not that interesting, but basically the job ran, it was successful. And since this doesn't return anything, you can't see what it did or what it returned. But if now would be fun time to like split this profile and run things separately. So I'll just disable workers from here.
Okay.
I'll disable everything from here, which is not required. Watch also. And now we'll run bench worker separately. So you can see what the worker is doing, and it's not like because this has all other messages which is annoying. So let's try to enqueue it again and see what happens. So it received the job
Awesome.
for sleep. It is executing that job. It will probably take 5 or so seconds, and then it completed and it stored the results of that.
Okay.
So uh, this is how all background jobs work, where you and there is just this simple interface to it. There isn't anything complex apart from this. The complexity is in the details, but the interface is very simple. You just say, give me any pure function. We send it to background, and some other worker will execute it. You can specify the arguments that it should be called with. That's it. Right? There isn't much else to it. So now we'll try to see the implementation and other complex bits. Uh, so Frappe right now uses something called RQ. It is this library which is written by cool people, uh, which does all the heavy lifting that is required. So Frappe for background job just relies on this library. Doesn't do much of our own apart from the Frappe specific things that we will see. But if you look at this, somewhere here, NQ jobs is due NQ a function here. So like we have just wrapped this basically. Like when you do frappe.nq, we do some magic and then we just say rq, please nq this job. And then there is a worker. So rq worker is a command that you run. We have similar thing called bench worker, which again is just wrapping the rq worker with some extra bits. And let's see how or what it does one at a time.
Cool.
So let's try to first explore this bit more visually. So uh, we have something called RQ worker, RQ job. So any job you want to see, let me, yeah. So let me do this again. We will enqueue this job. It will appear here. It is started. So the status is started. It will take maybe 5 seconds to run. Then it will finish. So a job came in. You can explore, by the way, all background jobs here, but they are only stored for like 5 or so minutes. So you cannot, like you can see live while debugging, but they won't stay here forever because that will take a lot of memory. So let's see what this job contains. So if you see what it contains, like all the arguments that are passed, which queue it went to, what was the timeout, etc. Like there is a lot of information here, which is useful to understand how this works. So the fun parts is this, like the method we specified is sent as arguments here. Then the name of the argument set is specified, like duration should be 5 is also mentioned here. And all of this is used by the worker to find the right job and execute the right job. So we'll see the worker, how the worker does. And if you recall how to find things, you just do command star worker and it will probably find where the worker is. So any command that you see in bench, you can just find it like this. And let's try to look at that one now. So bench worker takes a bunch of arguments. like which queue to consume, etc., etc. I haven't gone into queues yet, so it'll take some time. But like for now, let's just assume there is one queue of jobs and worker consumes that queue. So we start the worker by calling this function, which is start worker, and it does some things which we can ignore. The most important things it does is it initializes a site to get the Redis connection, because we need to ask, like check that Redis connection for consuming the queue. And ultimately, like it does few things for logging, for setting up, for making it nicer, or etc. But ultimately, what you do is we just call RQ worker and worker begins work, worker dot work. And this goes on infinitely, like it doesn't terminate ever. It every now and then it will just check, does it have a new job to do, by and like Redis will basically tell us that we have a new job, then it will fetch the job and work on the job. So we don't need to go too much into how the worker itself works, but this is how it is defined. And now the fun part is, I don't have the diagram for this yet, but there can be a very complex configuration for workers. So I will start by explaining the one that we have seen from, which is uh, which is this, where you have a, and the same thing exists in prod also. So you have bench worker queue short. You might have seen this worker short, and you have three different versions. Uh, Here there is a, instead of short you have default, and last one is you have long. So if you okay, short long. So you can have multiple workers like this, and in production you do, because just one worker is not enough to handle all the load. Uh, in most cases, if you have a decent enough site, you will have multiple. So what this is there are multiple queues and there are multiple workers consuming those queues. And when you don't specify anything, the default thing that is in your profile, it is basically this, like consume all the queues, short, default, long. So you don't, for development, you don't need all of them, but like in production, you might have three different workers doing single. Uh, what you might also have is something like this, like where one worker is consuming these two and another worker is consuming these two, these three. So you can mix and match all of these in to like optimize the, like reduce worker count while still doing the throughput, the increasing throughput stuff. So this is what we run in production, by the way, at Frappe Cloud, or like in our production deploys. This is how we. So all these weird configurations, uh, we need to see why these exist, or why they are useful. Like why not just have simple queue and simple worker, like it is there in development world. So the problem begins when you start having complex jobs. So let's do this. Like right now we don't have multiple workers, right? So let's do something. So we have few jobs. Uh, let's do duration 500. Uh, I don't know how long that is. No, let's do 100, like for sake of demo. And let's do another one for 5, another one for 10, another one for 50 maybe. So now if you come here, you see there is one job which has started and there are three jobs in queue. So,
Okay.
and this job is gonna take 300 or like some 100 seconds. So it's gonna take a lot of time. And while this is going on, like everything else is basically stuck. So that's why we have this concept of different queues for different kind of jobs. If you know for sure that your job is gonna take long time, then you specify that put this in a longer queue so that thing works, and then there is another shorter queue which has all the short jobs which can just keep running. So we'll see, like we'll just, maybe we'll not wait for 100 seconds. Let me just kill this.
100 second is how much? Like 100 divided by.
Yeah, so
It's like
the
1.5
better
minutes.
so better option would be like we can have a bench worker which is consuming queue long, and then there is a bench worker uh, which is consuming
Default,
queue
maybe, yeah.
short
No.
default and maybe long later. Like if the work is done, then log. So now we'll again restart the bench. Hopefully it has cleared all the jobs. Uh, yeah, there aren't any jobs. So let's try like we'll start these workers. And now there are two workers doing two different type of work.
Mm-hmm.
And we'll again simulate almost similar kind of here. So we have 500 duration, but this time we'll tell that this job is going to take a long time. So put it in long.
Okay, so this we have to define, right? So
Yeah.
by default, it doesn't like.
Yeah, by default it will not because we don't have any way of knowing. So it will not specified by default. So now if you see there are
Two jobs
two
started.
jobs started. They are being handled by two different workers and one job finished also. And two jobs finished. So all the short jobs are finished, but the long job is being handled by someone else. So if you
Mm-hmm.
see queue specified, so default jobs are already finished and so they are not affected by long time job. So this at least broad classification of whether your job is going to take a lot of time or not, you should do, and accordingly you should put it in the
Q.
right queue.
Mm-hmm.
Uh,
Makes sense.
there are some other good practices also, like you shouldn't have a job that runs forever, like 20-25 minutes. You should break it down in pieces and like in general, like 100 1 minute jobs are better than 100-minute job because at least each job will make some progress. So those are just good practices regardless of which framework you use. Uh,
Yeah, it's again like
so now,
parallelism versus serialization or something.
yeah. And also you want to make sure progress happens and it's
Mm-hmm.
not just stuck.
Yeah.
So there is another doc type called RQ worker where you can see all these workers. So if you are facing any issues with like background workers or yeah, like first thing you should do is check these two out. And so they will have all the important information for debugging or monitoring if the things are working or not. So these are the two workers we started with bench worker command. And as you can see, this one is responsible for log and this one is responsible for three different queues. And if you open it, you can see which job it is running at. Like there is some meta information like is it busy or it hasn't done much or there is utilization like how much time it spent actually working. So like this one might have some time. Since it started, 11% of time was spent in actual work and the rest it was just idle. So all these things sort of help when you're trying to debug background job related issue, but right now we just use it to explore like how workers work. And if I add one more worker, you let me add one more worker, which is queue just default. It will show up here. Yeah, it showed up here. You can see when it was created just now. Uh, so that's about
Cool.
worker monitoring.
Mm-hmm.
Uh, we also saw the job monitoring. Now they are done. Now let's go a bit into depth and how these are implemented in code. So I'll
Cool.
kill all the unnecessary ones. Uh, anyway, we'll not be running them. So let's go to init and wait, where am I? NQ. Yeah, so NQ just calls another function. It's just outside, like it is there in Frappe namespace just for sake of simplicity. But it calls this function which does a bunch of things, and it does a bunch of things, and then it just gets a queue, like whatever queue you specified. Uh, like all of this is not interesting. I'll hide all this. It's just some handling of some old edge cases and stuff, which you can ignore. This deduplication, but also you can ignore. All jobs are also async. Anyway, so the first thing we do is we build some kind of job ID for your job, which is just random UUID. It's nothing special with your site name appended to it. So you can filter by it. Then we get the queue, like long queue, short queue, whatever. The queue is just a connection to Redis, and then we insert things in that queue. And we build the arguments for the queue, like what you need to do. So like which site it is for, which user triggered this, and all these things. And this bit is important because if you don't specify which, like you don't have to, but if Java framework doesn't specify which site it is for, then all that information is lost. So this site is passed on, so you can have multi-tenant deployments where same set of workers can be working on all the sites. Like you don't need a special worker for each site. The same way we have for web worker, where same worker is responding to all different sites. So all these information is just what you passed, and the arguments are passed here. And here, some one weird thing happens is we create a function which will enqueue the call, which will put your job in the queue with all the arguments. And in most cases, you want to use this, which is called enqueue after commit. And so if you specify enqueue after commit equals true, then the job won't be immediately enqueued. It will only get enqueued if the whatever you did was successful. So let me write a sort of an example for when this is useful. So let's just say user will write another function here called register user. User. This is a made up example, so just, just tolerate it for now. So let's say you are accepting some registration and you do frappe.get register user. You do something like a user.insert. You might have some kind of workflow like this, and somewhere in here you also want to send an email. So user like send registration email, and you write some function, and you don't want to call it, so you do it like this. You enqueue it instead of and user is user, something like this. You enqueue it, and then you do insertion and some other work and say that yeah, we have registered. Now the problem is here. The problem is like you have enqueued this job. That job has already begun. Like whether this registration was successful or not doesn't matter to that job because it has no idea. So like, it will just send the registration email to that user that yeah, you are registered to, but they are not actually registered, because what can happen is during this insert some validation can fail. So what you really want to do is either do this, but the safest option is do this enqueue after after commit. So this is sort of a common pattern that you will see in a lot of places where if you have some kind of external IO which is done in background or something like you are modifying some file, etc., you should usually defer it after commit. So when everything is successful here, the database will make sure that whatever job you have deferred will be done after the commit has been made. So I can show you how this happens after commit. So basically FrappeDB has this callback manager for things to do before, after commit, and when the commit is made, like your changes are committed, like user is inserted and the changes are done, then only we run everything that we specified to run after that. So we put it in the Redis queue. So it will go to the queue and things will start getting consumed by workers. So let's see what happens when you don't have any workers attached to it at all. So you can see how the enqueue works. So we enqueued a whole bunch of jobs, and if we go back to the RQ job page, they are all waiting here with no one to work on it. So if there is no worker, they will just stay there until some worker actually comes and starts working on it. So if we again start a worker here, it will connect to it and start consuming. So you have to understand sort of like somewhere there is like in Redis, we are maintaining a queue of things to do, and that queue you can visualize with RQ, but the simplest example is probably like there is a list of things you need to do and you keep adding to it and you keep popping from it. I'm consuming this job and I've received a new job. So now we started worker, it completed. So that's roughly what happens. So we just do enqueue call to RQ and we just let it do the real heavy lifting of managing multiple workers and multiple people enqueuing things to it. That's
Cool. Yeah, one thing to mention here is like the doc types you just saw, that RQ job and RQ worker, they are both virtual, right? So
yeah. So
that's
these things are like none of this thing is saved in database. So when you request, when you go to this list view, it just calls Redis and checks which jobs are available, and it just shows you all the jobs. Uh, you can maybe see that also. Arcu.job.py.
Voice is breaking a bit. From whose side, Maharshi? Like mine or Ankush? I don't know. Like my internet bandwidth went low for a bit. Now it is fine. So the voice should be fine, I guess.
Uh, cool. I can explain a bit about how this works. So that will also help you understand how the internal implementation is done. So uh, virtual doc types are basically doc types which are not stored in database. They are stored in some other database somewhere else. So this is sort of a hack because we don't want to build like same UI for list view for visualizing RQ job or like RQ worker. Like you can just use the list view because it's just a list of jobs.
We
So
had a UI,
we
right? We killed it after
yeah,
this.
we had a UI, we then killed it because it's like better to have consistent UI for things. So recorder is also getting killed and have the same UI. So what it does is like you override. So virtual doctors basically override few things like load from DB to instead of to loading from actual instead of loading from actual DB, we load it from RQ. So we basically call RQ function for fetching a job. So when you do this, like this is the job ID. So which is the document name also, it's some UUID. So we just fetch it from RQ and whatever the job exists, we just serialize it, we just convert it to dictionary or then convert it to document, and that is sent to you as a form. So you can like you get some kind of a simpler form without doing anything. Uh, Same interesting bit would be here, the get list bit. So when you go to list view, it fetches all the jobs that are matching the filters. So if I say queue failed, then I'll only get, sorry, if I say status failed, then I'll only get failed jobs. So this is also again entirely done by just asking RQ to give us failed jobs or give us in queue jobs, or then just fetching all those jobs and synchronizing. So something here failed, uh, which doesn't have any, yeah, doesn't have any exception. It just says it was abandoned. This is because I just control C the worker and just killed it. Anyway, uh, so this is roughly how background jobs work.
Awesome.
There is another. If you have any questions for background jobs, you can start. You can ask now, or we
Yeah,
can
yeah,
go
ask it
through
in the
schedule.
chat. I'm like reading the chat constantly. Literally looking at it for since the start.
Is there any question, or should we jump
So
to
there
it?
is one question. When I change scheduler underscore events in my apps hooks.py, does it sync with site's schedule job type automatically or I need to delete it manually?
Yeah, we'll take that question when we do schedule, which is next. So if there is no other question, then we can jump.
Yeah, yeah, there is none.
So background jobs. By the way, background jobs also have this one fun thing. So we are also wrapping RQ jobs. We always enqueue just one function called execute job. So framework has something called execute job, which executes job regardless of like which method, which whatever you specify. So RQ is just executing this function. Then framework decides what function you have specified and finds it, etc. So if you look at this, it's pretty same to how a request is initialized. So like we initialize with we connect to Frappe DB, then we set the user, then we do some jobs which we are supposed to do before executing job, which is same like we saw.
Yeah,
Like
before
you run,
request. Yeah.
yeah, before request and after request, you have similar things here also. Then we just run the actual method with whatever arguments you have specified. Here we are not so tolerant where you can just specify arbitrary things because uh, this is in code, so we are assuming that you have only specified what is required. So we just get the method and call the method. Again, the same thing, Frappe get at. If it was successful, if it was not successful, then we roll back. If it was successful, we commit, else we commit. So, and finally we just run the same thing that you asked, like after job what. So it's very simple. Like it's way more simple than request also. There, the job is just you get which method to run and you try to run it. If it fails, you go back. If it succeeds, come back. There is some weird edge cases here. Like it's just for making it a bit more robust, like where there are retries and some logging, but none of that really matters in understanding broadly how background jobs work. So the next bit was uh, scheduler or how that works, and the question on if you modify, does it reflect automatically? Or not. So let's do this. Start file. Uh, there is scheduled events, scheduler events. Yeah, these are all the events. It's raining. Just keep this.
Yeah, it's like noise from your side. So
Uh, okay. So scheduler events are basically events you need to run at some specific frequency that you specify in books. And by the way, there's some voice from some voice from. Yeah, that's right. So scheduler events, by and large, are background jobs only. Like we people keep getting confused between them. These are background jobs that are just automatically executed for. So you want to, let's say, fetch email account or email from their email account. That needs to happen continuously. Like you want some user doesn't need to go and ask like now I want to fetch my email. So the way this works is like we specify some frequency. So there is some cron frequency, and then there is hourly frequency, etc. And every hour these jobs are active. So again, we'll try to understand how this works. The first thing you should see is like where is this in profile. So uh, profile is so in profile there is something called schedule, which calls bench schedule. So since this is again a command, we try to find the command by doing command schedule, and you'll find it. Here there are some more. So this is the actual command. Let's jump to that command and let's see. So there is a command called start scheduler, which calls this function. And here the like true simplicity of this begins. Uh, it is literally a infinite loop where it starts, it sleeps for some tick, like for 60 seconds it won't do anything. Then after 60 seconds it will check like are there any jobs due, and if they are due, it will complete. So that's about as simple as things get. Uh, there isn't much else to how to check it out. Once we start going into individual functions, we'll see how the logic works for comparing others and on that. But broadly, it's just one giant infinite, which just sleeps for a while and two jobs, again sleeps for a while and two.
your voice is breaking a lot, Ankush.
It's probably the
Yep. So till then, I will answer Ashish's question. So Ashish, you can use this tool. So this is what I use to like get your cron expressions to a human readable form, right? So you asked like 2:50 a.m. and 2:50 p.m., right? So 50 hours past 2 and 14 exactly. Correct. You can check the link as well that I have sent.
is
So
my voice here because I
you might have to speak a little louder, I guess. I
okay,
don't know.
just give me a second.
Yeah, sure, sure. Yeah, cool.
Can you see me?
Yeah, you are visible.
Okay, so I had to just turn on. It's raining, so there isn't much I can do.
Ha,
But
fine.
we are nearing the end, so let's try to go through this.
Yeah.
Uh, so So scheduler just calls this one function again and again. So we'll see what this function is. Uh, this function just initializes for each site that are present in the bench. For all of them, it increases the pending. So it's again like a for loop which constantly runs. So we go to that, uh, which again calls one more function. Because like the simplicity is just in like it's just because of abstraction. But if you go through all the if you expand all the code, then it is also complicated. The way we do it here is this: we get all the scheduled job type. So this is the job type where whatever you specified in hooks is translated to. So I'll show you this. So someone asked scheduled job type: are they migrated or are they new to segment? So scheduled job types are like whatever is there in hooks.py is migrated here, and it is only done when you migrate it. So when you do Frappe, bench dash dash site migrate, that's only when your hooks.py data is updated in the database. It is not automatically done. Uh, there are reasons for not doing it automatically, because you might have ordered this, you might have some extra detail there. So we don't read hooks.py while in production. We just read this because you can also disable it. So these things cannot be done in code. So roughly what happens is when your site is created or updated, we read the hooks.py file, and whatever you have specified, we create a equivalent version of it in here. And when you update, the updated details are also copied. So if you see what it's doing, it's just some method. And if you remember background jobs are also just some method you need to call in background. So scheduler just does this. Let's go back to code. It sees this. It gets all the scheduled job types and it calls NQ on them. And we can see the method by going to the NQ. Schedule job type. It's here. So uh, if you see this, this is the true final thing that happens to schedule jobs. Is that we check is the event due or not. That means like we according to the cron expression or the whatever expression we specified, they are. If the job hasn't ran in last 1 hour, then we NQ the job. So the NQ is again, this is just Frappe.NQ library. It's not something special. So Frappe.NQ that job with whatever the queue should be. So there are two queues for some jobs require more time. So they are in long and some are in short. Uh, and we specify what is the method in the job. Some more things are added for reduplication, but that doesn't finish. And the logic for whether the event is queue or not is somewhat straightforward. So we compute where this view next according to your where this view next. So we will show you the code as well. So all the things that you see yearly, monthly, daily, etc. It's just mapped to some kind of cron expression. You can specify cron yourself also, but this is simpler to understand. And most of the time, you just have like hourly, daily jobs, not like very specific cron. But you can specify cron also, but there is a site called cron dot yeah. And if you paste the cron, you will see at minute zero run this. So every day at minute zero run this. Next one will be today midnight or I know this is every minute at every hour. So daily would be something. So I will not explain cron because that you can kind of learn. But
Yeah, yeah.
basically every expression is just converted to some kind of a cron.
Yeah, I have dropped
Uh,
the link in the chat as well. Like
so
crontab.guru.
and based on cron, we just use this library to just get when it is supposed to be executed next. And if the next is past the current time, then we execute. So That way, scheduler is quite simple. It just keeps checking if these are running or not. If they haven't run, then you just run them. Uh, does that answer your question about whether you need to sync or not? So every time you modify this, you have to run migrate. Then only it will be synced.
Ashish, does that answer your question? I think it does. So there is one more question that Gurshin has asked. When we write the command to start a worker or kill the worker from proc file or otherwise, it will essentially spawns up the RQ job worker, right?
Yeah.
Yep.
So it essentially spawns RQ worker, but you cannot just spawn RQ worker because we are doing some customization on top of your
Mhm.
RQ. So you can't just spawn RQ worker and expect it to work well. Uh, it might, it might work. I have never tried, but that's usually not a good. And the way RQ works is also RQ has fantastic talks. So if you ever need to get too much into it, you should definitely start with how RQ works and like how they do this thing. So it's not they have fantastic stuff and RQ is also very simple. Like it's not something like salary where you have to do PhD to understand all of these things. It's very simple and like the language is very simple to understand. Code is also simple. It's Python code. You can go into the code and read that also. So I will just maybe explain this. But so worker lifecycle is this, where worker starts, it prepares for when it is ready to execute the job, and then it starts listening. So this is what when I said it starts listening to Redis, and when Redis says that it has some new job, then it will prepare for job, and uh, this gets a bit technical here. So basically, RQ doesn't execute the job in the same way. So it forks the main process and creates a whole another process and executes the job in that process. So it's cleaner, secure, etc. It doesn't pollute the main process. And then the job completes, the that process terminates, and you come back. If you want to see, and then this is an endless loop. Like it gets a new job, forks the process, runs the job, comes back, finds a new job. And it just keeps running in the loop. If we want to see this in live, we can probably do it, assuming the Q code is still there. So if you do this, let me enqueue something with long time. And is there any worker right now? It stopped. I'll have to slightly make this screen smaller. You can't see it. Uh, so okay, so there is no worker running at all here. So let's start a worker and to consume that job. So it has found that sleep and it is doing work on that. Now if you see this, if this stops updating, I can show you. Yeah, here. So if you see this, there is a process we started. It forked the main process to run the job. So this is where the actual job is running, which is inside another process. So there is one new process started for every job that runs. And once that job is completed, that process ends and you go back. Let me let me kill this and go back. Now you see there is only one process. And if we send the job again, it will again have the it will start it will start the job in new process. So this is the process that responds. So if you see the tree, there is one more in the tree. I don't know if it is visible properly. Maybe Hussain.
Cool. So we are like past 2 hours. Is there something else that you wanted to cover, like core stuff?
Uh, Not much. Like just in related to these, I can still answer if someone has a but
Mm, yep. You guys have any question? Please drop them in the chat. We'll take them now.
yeah, that job ended now 50 seconds.
Yeah. Cool. So you were saying like, okay, it will take like 1.5 hours, or how much content we have? It was like past 2 hours, and we still have like stuff to cover, right?
Yeah, yeah. So we can do another session if people are interested with some
Yeah, yeah.
other topics. Definitely
Yeah,
up
yeah.
for it.
Each of the
Maybe
topic that
after.
we took today can be like a separate live stream of its own. Driving through, like looking at some examples, digging deeper. But I think this gave like fairly good idea to some experienced Frappe folks, I guess. If you were knew like some, yeah, you. So Alberto said you killed us. So yeah, it was given like disclaimer was there. It is for like not beginners. So Tahir, can you please answer my questions? So, Frappe UI, right? So there is something called real time that you can ask, that you can add to your list resource, and it will basically use Socket.io to update it. So Congru text, thanks you all. I couldn't understand anything. That's fine. That's fine. Like rewatch 2 months later, maybe after you have like more experience in Frappe or whatnot. If you do have experience, like rewatch maybe at, I don't know, 0.75x or something. That's fine. Like keep bookmark it
So
for
what
some
we'll
time
also
later.
try
Yeah.
to do is like
Mm-hmm.
uh, we are also like I'm also trying to convert these to text form
Yeah.
over time, and then like text is much easier to consume because you can take your time and just
Yeah. Yeah.
go through things.
Right now you can rewatch maybe like, because it was like a 2 hour long session and attention span goes here and there. But yeah, maybe I will chapter it according to the topics we took, and then be easier to parse. Yep.
Cool.
Yeah, now we like, this
Let's
was the
wrap.
most technical session of the collab month. We did it like head on first, and now rest of the stuff is like low code, no code, and then setting up insights, working with, yeah, cool stuff coming. Yep. Thanks dash dash open minded about framework. So Kenneth says, okay. Cool. Do you guys have
Cool,
any
cool.
questions? Thanks Ankush. I had to make a deal with Ankush to convince him to come. But yeah, it
But I
was
had to
fun.
come anyway.
Yeah, yeah, you had to come. Yeah, we'll
Anyway,
have.
I had fun like just trying to go through these things. I also got some
Yeah,
ideas to
yeah.
like what we
Even
can
I
do
like
better.
picked up few things. Even things like that string formatting trick. Even like the thing you used to trick, basically when you forgot to assign something to a variable in the console, and you used, okay, variable equal to underscore. That was new for me, and it's quite useful because many a times I do this, and like I run some function and then I don't catch it and store it in a variable. So that was cool.
Yeah, those things are fun. Like so the again like these videos help to some extent, but the best way to get into
Yeah,
something is
advanced.
read docs and read code
Yeah,
and just
that's the
like
only way. Yeah.
code.
Yep. Even in, so today you can think of like, what did we build, right? We built concepts. Maybe you can some use those concepts to dig deeper in the code base. Cool.
Cool, then let's wrap.
Yeah, yeah. Let's
Bye
wrap.
bye.
Yeah. Goodbye, guys. I will end the broadcast now, and we will see you guys in next week.